Welcome back to Further Solutions Academy. Further Solutions Academy. Encourage us more to share and also subscribe. If you have not subscribed before, make sure you subscribe. Presently, we have over 250 videos on our platform. It means you can come here and learn any topic of your choice, and also mathematics is available for you free. Physics also is available, and chemistry also. Where I'm on physics, which I'll be working on measurement of heat energy. Measurement of heat energy. Now, those are the outline of this part. Before you watch this series, make sure you understand or you watch temperature, conversion of temperature, and the scale and other things, which is already on our platform. Now, measurement of heat energy, the outline are: one, specific heat capacity and heat capacity. The second one is method of mixtures, electrical method, temperature difference in a waterfall, and latent heat of vaporization. Now, on each of these outline, it will produce one video on each. It means on this part, we'll be having 1, 2, 3, 4, 5, 6 video on this topic. Now, I will start with this, which is a specific heat capacity on the first one, which is what I'll be working on this video. Okay. Now, what is covering then is heat measurement of heat energy. Now, on this video, I'm working on specific heat capacity and heat capacity. That is what I'll be working on this part. It's a very common part of our topic in our examination, international exam, and even here in Nigeria examination. Now, I want to be working on this part of this physics. Now, when you hear a word specific heat capacity and heat capacity. Now, in our previous video, I've explained what is called temperature. The scale of temperature, and the mercury, the function of mercury, and so on and so forth. Make sure you understand that liquid in gas, mercury. Now, but let's talk about specific capacity. Now, when heat is added, to or removed from a body, the temperature change expected depends on the mass of the body and its specific heat capacity. As equals to MC bracket of Q1 minus Q2, or Q equals to MC of this. Now, those are the things that we will be talking about. Now, when a temperature is added or is to remove, something will happen. Those are the things that will happen. The first thing is what? The quantity and the mass of the substance. And this is known as specific heat capacity. While my Q, which is my tilter, we have final and initial. I told you to find the difference between 2 points. You must start from end minus beginning, which is final and initial. Now, let me define these terms. When we have our Q, which is known as quantity of heat energy. Quantity of heat energy, which is always in joule. Please, it's always in joule, because purely we are talking about calculation here. It means your unit is very, very important. Be sure you understand that very well. Now, when we talk about Q, and my M is talking about the mass of the substance. In kilogram. In kilogram. And also we have my C, which is known as my C is known as specific heat capacity. Specific heat capacity. And also I have my Q2, theta 2, which is, we call it final temperature, and which is always in, it can be Celsius, it can be Kelvin, and can be Farad. I've told you earlier, that was what I was talking about then. And also my theta 1, which is, it will be initial temperature, which is also Celsius, Kelvin, or Farad, either of the three. Now, that is what specific heat capacity is all about. Now, there must be what? Removing of temperature. Is there increase of temperature or decrease of temperature? Now, where I am in my studio, if the temperature of this particular environment increase, it means there will be increase on my temperature. And if the temperature decrease, maybe AC or something else, also will decrease. Now, that is what is called this change. Now, we are being used this, that, which wherever you have this, it means change. It means change. Change in. Now, when there is change, there must be final and there must be what? Initial. Now, that is what is specific heat capacity. Now, also we need to know that specific capacity, which is thermal capacity, the specific heat capacity in specific heat capacity, which is also called thermal capacity. It's also called thermal capacity, which is C of a substance is defined as the heat required to raise the temperature of the substance by 1 degree Celsius or 1 Kelvin, the S standard units, which is units. Okay, in what is joule per Celsius, joule per Celsius. Now, or joule per Kelvin. That is the what I need to understand. That is very important. That is first one. The second one, which is I'll be talking about specific capacity. Also, let me also define specific capacity. The specific heat capacity which is C of a substance is defined as the temperature to raise okay, as defined as the required, it should be as the heat, as the heat required to raise the temperature of the substance by 1 Kelvin or 1 Celsius, 1 degree Celsius. The SI unit is joule Kelvin by gram. That is the SI unit. Or you can have it this way, or joule Kelvin per gram per Celsius. Either of the two. Now, I want you to understand that heat capacity C is related to specific heat capacity. As follows: heat capacity equals to mass multiplied by specific heat capacity. Now, it means my heat capacity, which is known as C, is equals to MC. That is what that means. It means my C equals to MC. Now, since I have it like that, it means I can say that my quantity of heat, which is Q, is also related to heat capacity, which is my Q equals to C bracket of Q2 minus Q1, or Q equals to C of Q of change. It means, which I've told you earlier. Now, it means my quantity of heat equals to heat capacity multiplied by temperature change. Now, that is very, very important. That is very important. Now, when we talk about what is heat quantity of a substance, okay, now what is the quantity of heat? Okay, before I give this example, with what I've given you now, we can solve any question. We can solve any question without any problem. I've talked about specific heat capacity and heat capacity, and also their units, their SI units. Please take note of that. Please, this is very, very important. My heat capacity equals to mass times specific heat capacity. And I've told you that I've defined all this earlier, that this is final, which is this is final temperature, and this is initial temperature, and this Q means quantity of what? Heat capacity. This, my C, is specific heat, the heat capacity, which is also, I've explained that. This means change in temperature. Change in temperature. And there's no way we talk about change, it must involve final and initial. Now, let's move on to a problem. I wanted to give you a problem so that we'll be able to see how it goes. Now, let me give a problem that will really help us. This question comes this way. What is the quantity of heat that will be given out if a bar of brass of mass 350 gram is cooled from 95 degrees Celsius to 20 degrees Celsius. My specific heat capacity of brass is 380 joule kilogram per Kelvin. Joule kilogram per Kelvin. Now let's try to work on this problem. Let's see what will happen. Now, I've told you it's a very simple one, which I've explained earlier, that when we're talking about heat capacity, quantity of charge is always equals to mass, and which I've told you earlier that we have what is called my QO. Sorry, solution is very important. We're now on the point of solving. Now, it means my Q equals to what? MC of change of temperature. Now, I've told you that this is temperature, why this is mass, why this one is specific heat capacity, and this is called quantity of what? Of heat, which I've done that. Now, my mass from the problem, my mass is 350 gram. Now, I cannot use gram. I have to convert it to something which is kilogram, which also implies 0.35 kilogram. Now, my capacity, which is heat capacity, is 380 joule which is a joule per kilogram per Kelvin. Joule per kilogram per Kelvin. Why Kelvin? It means I'm writing this also. I can write it in form of 380 joule divided by kilogram and Kelvin. That is what we are saying. This is also the same thing. Please take note of that. It means an inverse. I'm using inverse approach. Now, since I know that my temperature change, this temperature change, it means I can say that my temperature change can be equals to Q2 minus Q1, which I've told you earlier that final minus initial. What is our final? What is my final is 95 minus 20, which is they're working on degrees Celsius, which I'll be having 75 degrees Celsius. Now, it means I can now approach what I'm having here. It means I'm looking for the quantity, my specific heat capacity, which is of the brass, the specific heat capacity, mass of substance. Multiplied by specific heat capacity multiplied by change in temperature. This is mean equals to heat energy given. Out. Now, I think I've done that earlier, which I will have my Q equals to, what is my mass is 0.35 multiplied by 380 multiplied by 75. Now, that is what I'm to have there. Since I have that, I can now say that my quantity, which is also equals to, I multiply everything, which is I'll be having 9,995, 9,990, 975 joule. That is my final answer. That is my. Please make sure you put the unit on it. I've told you that quantity is always joule, which that is all. That is all about that. Now, let me give more example on this part before we end specific heat capacity. Now, I have this question. Calculate the final temperature of 25, of 2 kilogram of alcohol at 25 degrees Celsius when is 20,060 joule of its energy is added to its specific heat capacity of alcohol 2,520 joule per kilogram per Kelvin. Now, I have this type of problem. How do I solve it? Solution to this question. The first thing, I'm looking for what? Final temperature. It means my Q2 is on question mark. I don't know it. But other things are given. I have my quantity, which is energy required. Now, the energy given to us is always equals to the energy given to us is equals to 20,160, which is joule. I've told that, I've write that, and also my final temperature is 25 degrees Celsius, and the specific heat capacity of the substance, which is 2,520 joule per kilogram per Kelvin. Now, since I have that, I can move on by having my Q equals to mass multiplied by the specific heat capacity, which is change in temperature. It will be final minus what? Initial. Since I have this, I can now substitute all what I'm having here. I know my Q, my theta 2, which is the final temperature, is not given, and that is what I'm having. It means 20,160 equals to 2 multiplied by 22,520 bracket of Q2 minus 25. Now, by so doing that, I can do my multiplication, which I'll be having 50, 40, which I have my Q2 minus 25, which also be equals to 20,000. Now, I can now move on by having 25,040 theta minus 1600, which is also, I have this and have that. Now, since I have that, I can now continue by having my temperature, which is I'll be having my theta equals to 16,000 after correcting light times, 600 divided by 5,040. My theta 2, which it will be equals to 29 degrees Celsius. That is all about that. Okay, with all about that. Now you can see it's very simple. They are simple mathematics. The most important thing is just to understand and be able to interpret, which is break down on what you are given. Now, let me give the last example on this part, which is the specific heat capacity. The temperature of a piece of metal of mass 9 gram is raised from 10 degrees Celsius to 1110 degrees Celsius when it of its energy. Determine the specific heat capacity of the metal in joule per kilogram per Kelvin. Now, this is what I'm working towards. Solution to this problem. It's a very simple one. But what you are working on the specific heat capacity, which you are looking for C. Now, don't forget that my Q, which is my quantity of required, is always equals to mass of multiplied by specific capacity bracket of change in temperature, which is final minus initial. Now, since I have it this way, I cannot continue by having what I'm looking for. I'm looking for this C. I want to make C the subject formula. It means I can say that my C, for those that you should be able to understand anyway. Theta, Q of mass bracket of minus this and that. It means at this point you can put your numbers, which this is this, and also my mass is 9 gram, which also I will convert it to what kilogram, 0.009 kilogram. And what again am I working towards? My Q1, which is initial temperature, my Q2, my theta 2, which is final temperature. I will have it, and I will put them in order like that, which I'll be having 108 divided by 0.009 bracket of minus 10, which I'll be having 108 divided by 0.009 multiplied by 100, which I'll be having, with this I'll be having 120 joule per kilogram per Kelvin. That's all. That is what I'm working on. Don't forget, you are on with further Solutions Academy. You can leave a comment below, and also you can reach us on this number. Before you do that, help us to share our videos, and also if you have not already subscribed, make sure you make a move to subscribe. Just press on the subscribe button. At this present moment, we have over 250 videos on our platform. It means you can learn any topic of your choice: maths, physics, chemistry, and so on. Okay, maths, physics, chemistry. Now you can reach us on this number 234-8034495990. With this number, you can call us, you can WhatsApp us, and also Telegram is allowed. Once again, thanks for watching.